So much for the opportunity to share my research today. I did my research with my counterpart, Lindsay Dahl. We spent our time evaluating the construction and reliability of an Arduino sensor that was designed by Dr. Wang and Yang Xiaofeng for in situ measurement of window efficiency. Our objective was to manipulate the home-based fabrication of the Arduino sensor that would be used to measure window efficiency. We were also testing the reliability of the sensor since it had never been used in homes, which is the intent of the sensor. Windows play a critical role in managing the comfort of living in workspaces. They impact budgets, they impact thermal comfort, and they impact the environment as well. It's important that consumers understand their windows, yet most consumers don't have a tremendous understanding of the specifics of their windows or their efficiency. In this figure, you see windows ranging from A, single pane, to G, triple pane. As you move forward in the diagram, the windows become more efficient. But often, other than knowing if you have single, double, or triple pane windows, you don't understand the properties of the windows. The National Fenestration Rating Council has developed a set of properties that help us determine window efficiency. We'll be measuring 3 of these properties with our sensor. U factor is the total heat transfer through the window. Visible transmittance is the daylight transfer through the window. Solar heat gain coefficient is the amount of solar radiation that transfers this heat. It's very difficult to determine outside of a lab setting. So in Dr. Wang and Yang Xiao's previous work, they found that solar transmittance was a good trade-off for this. It's the amount of solar radiation that passes through the window. Those are the 3 that our sensor will measure. Emissivity is important as well. Although it's not currently being measured, we're looking at it for the future. Emissivity is the window's ability to emit thermal radiation. Low emissivity would be ideal. On the right, you can see the schematic for the lab build of the sensor. It includes the LCD display where the data that's generated is displayed, 3 temperature amplifiers, and a light sensor. You'll notice for the home build, there are some important additions. To the 3 temperature amplifiers, we've added 3 temperature probes that are housed in 3D printed blocks. These blocks have a known R value. R value is the ability of a material to resist thermoconduction. So the blocks house these probes. This probe 1 is against the outside of the window. Probe 2 is against the inside. Probe 3 is housed within the block. You'll also notice that the lux sensor is attached to a 3-foot cord now to enable us to open the window and take an exterior reading and an interior reading. Lindsay and I each measured 1 double pane window 3 times. So we measured it once a day for 3 days. This chart shows the U factor of the double pane window, which is really the efficiency that impacts consumers most. The pink dotted line represents the expected U factor of a double pane window, and that's where we expected our results to fall. The green line represents the expected of a low E double pane window. While that would be optimal, we did not think that we had double pane windows. So our results falling down here showed us that we do not really have a reliable testing measure yet. We think there are a few reasons for this. I'm going to go over a few. The fact that the window has to be open to accommodate the cord for the temperature 1 sensor. The inability to calibrate the sensors in the home-based unit could also impact it. But most importantly, we think that the not knowing the R values for the blocks. The R values were measured in the lab, but the blocks we received were printed after that and not measured specifically. We think that there's an exciting reason to continue the work and a way that we can expand on it. We could develop a wireless module for the outside unit. That would allow us to measure those temperatures and test windows that are fixed or sashes that are fixed. Yang Xiaofeng is doing some really interesting research that allows her to isolate the energy costs that are tied to windows. We feel that if we married these two pieces of research, we would allow consumers to make a cost-benefit analysis of replacing or retrofitting existing windows. Also, we think that a light system that would allow home-based users to know when conditions are optimal for testing. Thank you so much for your time.